Good morning, everyone. Today we will be going over the anticipation guide you were supposed to be completing yesterday after reading the notes. So I will go over the answers just in case you are doing Gateway now and you missed this lesson. This should still help you go over the content from yesterday. So make sure you have your anticipation guides out at this time. From If you are wondering where this is located, check in the lesson from yesterday. You should already have this with you. The first part of the anticipation guide was supposed to be done before reading the notes. So if you could have marked them agree or disagree, because most of these statements are debatable based on how you understood or what you have based on your prior knowledge. So it wouldn't matter. You're good to go. Let's move to the actual statements in section 2. We were reading our notes for that. So first statement says, you feel like you are flung sideways when your car travels around a sharp curve because a force is pulling you in this direction. Well, so if you go in the notes on the second page, first paragraph, I have quoted the text from there. In reality, there is no force trying to throw you on into the door. Rather, you are being pushed in a circle by a normal force of the door, because otherwise you would go in a straight line rather through the car door. And I think we went over this on Monday also while I was explaining. Whenever object moves in a circle, it changes direction really fast. So let's say if you are driving, your car took a left turn, then what is actually happening is your body will try to keep going in straight line path due to inertia. We learned about inertia in forces unit. So it will take some time to overcome the inertia. For that reason, it seems like we are pressing on the door because car has already took a turn. During circular motion, while turning, car changes direction really fast. But our body wants to continue a straight line path. And due to that, we are pushing on the car's door. And it seems like as if we are pressed sideways, but nobody is flung sideways. So make sure you are thorough in your explanation. Quote the text if needed. If you need to pause the video at this time because you are still writing, go for it and then start the video when ready. Let's move to the next statement. Special type of forces are required to keep an object like a communication satellite in orbit around the Earth. Explanation. If you look at, I won't read the explanation. I got this explanation from the text on the first page. I think it's in the paragraph that any force or combination of force can cause centripetal or radial acceleration. Let's go back and think about the last unit. We learned different types of forces. We learned normal force, weight force, which is also known as gravitational force, applied force, friction force, tension force, air resistance. Any of these forces are capable of providing centripetal force. The name is special, but the force itself is not new. When car is turning, it could be the friction force providing the centripetal force. This is the stuff from Monday. I'm just going over here for explanation. So in case of satellite, let's take a moment and pause. What do you think provides centripetal force? What causes satellite to go in the circle? This is Earth and satellite is going around it. So what's pulling inside? Because centripetal force is center seeking force. It's going to be Earth gravitational pull on the satellite because we learned that Earth pulls everything towards its center, which is downward for us. Okay. So I will let you all pause the video and make sure you complete your statement and then get back to this again as needed. Next statement was, this is from yesterday, so students make sure if you're still figuring out where this is coming from. Object that travels at a constant speed around a circle have no net force acting on them. So again, we will refer to the same paragraph we did the previous statement from. According to Newton's second law of motion, F net equals mass times acceleration. For uniform circular motion, the acceleration is centripetal acceleration, AC. The magnitude of the centripetal force is m times AC. So first thing we learned, for object going in a circle, we need centripetal force, which is nothing but the net force. Now, we learned this during learning, when we learned first unit, even if object is going at constant speed and it's going in a circle, if it changes direction, it's changing its velocity or it's accelerating, in other words. That means acceleration is present just because object is changing direction. If acceleration is there, there must be centripetal force. And where is centripetal force coming from? It's the net force on the object. It could be one of those forces we talked about earlier. It could be anything which is providing this force. Let's look at the next statement, y'all. Bucket of water is attached to a rope and then spun in a circle over your head. The centrifugal force keeps the water inside the bucket. I did this demo on Monday in class by rotating the cup with water. What was holding water inside? I was holding on to the rope of string, and because of that, the tension force caused the cup going in a circle. I was not holding the water. Cup wasn't holding the water. Friction force won't be enough to hold the water. So what keeps water inside the cup or in the bucket in this for this particular statement is nothing but the Fichte's force, which we talked about earlier in the first statement. Fichte's force, which keeps the which is also known as centrifugal force. Okay, for that, due to that Fichte's force, it seems like that when object is going fast in a circle, it seems like they are pulled outwards. When people had no knowledge about, in olden days, when they didn't knew what this was, the common population called it centrifugal force because they thought there is a force pulling them out. No, there is nothing. It's just the inertia. So make sure you write it's a Fichte's force. Fictitious means fake. It's not a real force. It's just the inertia. This information is on the second page in the first paragraph about Fichte's forces. And to be honest, Fichte's means fake, so they are not real force. Make sure you clarify in your explanation. Water stays in the bucket or the cup because of the inertia, which is known as centrifugal force, but it's not a real force. Let's move to pause the video. If you need to write the explanation, get back to the video when you're ready. The amount of force required to make a sharp turn increases the faster you go. Well, if you look at the equation, you can look in the equation sheet or it's in the reading. Equation is over here. The equation for centripetal acceleration is v squared over r. And the moment I multiply this acceleration with mass, we will get equation for centripetal force. We will be doing more on the equations later, so don't worry about, you don't have to memorize the equations at this point. But if I look at the acceleration, is the moment I will increase the velocity, my acceleration will increase. So let's say if something is going in a circle and its velocity doubles, so 2 square is 4, acceleration will quadruple in this case. So if acceleration is increasing, means force needed to make that object go in circle is also increasing. So let's say, students, if we are driving, think in real life, look at the highways. When you enter the highway, most of the time on the streets, curved roads, it's written for safer turn, the maximum speed limit is 15 miles per hour. Why 15 or 20 or 25? Those are usually lower speed limits. Because what is providing centripetal force for car to make the turn? The friction. Friction is limited because friction force we learned in the last unit depends on the types of surfaces. Your car's tire and the road, they are going to be same. You will not have more than one certain limit of friction. So if the friction is limited and you go really fast and you need lot of centripetal force, there might not be enough centripetal force. There might not be enough friction to keep you going in a circle, and your car will start going in a straight line path because of inertia. Your car will skid, in other words. And that's why you should not go over the speed limit, the posted speed limit for safer turns. If it's 15 miles per hour, probably they came up experimentally. So if you go at 30 on that road, probably you'll need 4 times more acceleration or force. And if your car tire is not able to provide that, the road is not able to provide that, you will skid. So for that reason, I hope I have explained this enough. This should give you enough matter to write. Make sure you are quoting the text, as well as don't simply copy what you see on my paper. I just got the statements from the notes. Make sure you add your explanation to complete these sentences. You have to be thorough when you're doing this. Feel free to pull the anticipation guide, add to it. Okay. The centrifugal force and centripetal force are equal and opposite forces. Okay, so let's go back to what we learned about fictitious forces. We learned that centrifugal force is a fake force. It's not a real force. It's just nothing but inertia. So how can we even compare the two? Centripetal force is a real force causing circular motion. Centrifugal force is a fake force. So they cannot be compared. If something is not even a force, how can you say it's equal to something else which is a force? Okay, I hope this helps. How to remember the memory cue? Centrifugal, letter F means fake. We talked about this Monday. So I'll let you all write the complete explanation for this statement. Now, second to last statement, Newton's 3 laws of motion only apply to linear motion. New laws are needed to explain the circular motion. In the last unit, we learned Newton's 3 laws of motion are universal. Universal means they are always applicable. They are applicable to objects in motion. They are applicable to objects at rest. You do not need any new law for this. Okay, so for circular motion also they are applicable. Now, last statement is, while riding a roller coaster, you feel like you are pressed onto your seat because you are centrifugal, because of the centripetal force. I will let you think on this statement, write the explanation on your own. You can look for the quote in the text, anything. And I'll give you a hint though. Think why water stayed in the cup or the bucket. Okay. And then think what holds you on your seat. Is it the centripetal force or is it something else? I will stop this video here, complete this anticipation guide, turn it in the Dropbox if you didn't do it yesterday. Even if we are synchronous, you might be watching this video live. Feel free to ask questions at any point. Thank you so much, y'all. And then go over to rest of the lesson in the lesson instructions. Bye, guys.